Ladies and gentlemen, please welcome our next speaker, Hugh McKee, presenting the topic, Test-Driven Prompt Programming, How AI is Changing the Way We Code.
All right. Hello, everyone. Welcome to this talk. I guess I don't have to repeat the title again because I had this nice announcer do the title for me. But in this talk, I'm going to try and challenge you a bit. We're going to look at some of the things that are going on around us in the IT world. I'm a developer, so really from a developer perspective. And I'm going to take a chance, so it's my risk, but hopefully your benefit if it turns out this way. We're going to push a bit into the future. So as we know, and if there's a great group of people here, AI is just been crazy. Last year was the year that AI was unleashed from the labs out to the real world, and all of us finally got our hands on it. And last year was crazy. There was just massive series of it's never-ending announcements, and it's continuing into this year. We're halfway into 24, and just last week, for example, there were some pretty big announcements from both OpenAI on ChatGPT 4.0, and they always do this just before a Google event. The Google event was the next day, and then Google announced some pretty significant changes and improvements to Gemini. So it just keeps going and going, and it's just crazy. So this all started late in 22, in November in 22, when OpenAI unleashed, like I said, on the world, ChatGPT. And this is really after 70 years of development. I mean, there's been people dreaming and thinking and working on AI in one form or another since the 50s, since computing pretty much started. And it's been in the lab, though, for the most part, up until this last year or so. So the interesting thing, though, is that we can see this pace of change happening, and there's this anticipation that this pace is going to keep going. All these diagrams that I have in my slides are AI generated. Midjourney is for the most part, and I try and do a picture that's relevant to what the thing I'm talking about in the slide. So I kind of like the way this came out, even though it's pretty abstract. But there's some graphs that kind of go exponential straight up, but then some graphs that maybe plateau. And if you watch what people are saying, and I've been watching this space a lot all last year, I've been kind of obsessed with AI and things like that. Some people are saying we're going to have artificial general intelligence maybe this year, maybe next year. Some people are saying 2030. Some people say, well, maybe we're seeing this kind of very exponential growth, but maybe it'll plateau. Who knows? It's all over the map what's going on. But we're just definitely just getting started. But for us in IT, we know things are changing, and I love this picture again. This is, I think it was Dali that came out, and this is kind of conveys the way I think a lot of us feel. I know it's the way I feel. Was like I feel like a sand sculpture, and the wind's blowing some of this, diffusing me, and what's all this debris that's coming off of this figure. I feel like this is my skills and capabilities and experiences that I've had over decades of being a developer, maybe evaporating, going away. Things are changing, and really think about this, is that we're going to remember this decade. This is the decade when everything changed, is what many people are predicting. Most of the world doesn't realize this yet. I think all of us here do to some varying degree, but I think we'll look back in the future as the early 2020s. The 2020s is when the world completely changed. We went through a massive inflection point. We've gone through these before, but everybody that's really, and many people have said this, is that this is a big one. This is a really big inflection point. So I know I was experiencing this, and I know a lot of other people are, maybe you are as well, is like, okay, as you start to internalize what's going on, you get this feeling like, wow, okay, am I going to have a job? Or, I write code. Am I going to be writing code next year? A few years from now, what's going to go on? What's this going to do to people that in my family, my friends, all these types of things. So there's this kind of melancholy is a good word, and this weird feeling. But I'm an optimist, so there's also this like, wow, this AI stuff, man, is so cool. I just can't believe what we can do. So I have a lot of hope for the future as well, that we'll figure out how to deal with this. This feeling actually has a name. It's called Vesperance. The 3 QR codes down here are for 3 videos. The person that coined this name is a YouTuber. His name is David Shapiro. And I have a QR code on the last slide for the whole slide deck as well. But I just added a 3rd QR code because just this week he put out another video on this. And he talks about this feeling. And he's a really interesting person that talks about AI and the impact on humanity and all these different things. So I highly recommend you check it out. But it's not just about the machines. I'm not going to roll over and just say, oh yeah, okay, I'm out of a job. I'm going to have universal basic income and, just be in perpetual retirement. It's like, I don't think so. But it's really about how we can go forward, taking advantage of this technology and adapt to it. So that's really my strategy and a big motivation for this talk. So in this talk, there's 3 parts. Part 1 is the future is now, AI coding assistance. So we'll take a quick look at that. And then I start to push out a little bit. But this is actually on something I've been doing for over a year now, but I call it, and this is where I'm kind of pushing things, I call it micromind services, and I'll give you kind of an introduction to that and how it fits in with everything. And then here's the 3rd part. I really go out on a limb, and this is where I start talking about this concept of some form of test-driven prompt programming. So part 1, the future is now, AI coding assistant. So I'm a Java developer, Python, JavaScript, TypeScript, that type of thing, primarily Java though. But I've been using VS Code for a while, and one of the things I really like about it is the extensions in VS Code. And in preparing this talk, I just took a quick tour of the extensions in VS Code that are related to AI coding assistance, and there's quite a few. So you can see there's Codium, and one thing to look at is the number of downloads. So like this has around 600,000 downloads. Tab 9 is a bit more popular, been around for a while, almost 7 million downloads. Amazon has a couple million downloads. It's okay. But there's new ones coming along all the time. So there's no lack of these AI programming assistants that are coming out. The big one is Copilot, GitHub Copilot. I've been using that since it came out. Really enjoy it. It's 14 million downloads, and then later, after Copilot first came out, then they added a chat feature, which is also really nice. It's all built into the IDE, various IDEs that like VS Code, IntelliJ, things like that. It has 8 million downloads. Here's a fork of VS Code. It's called Cursor, and it's an AI first coding editor, but it's familiar if you're familiar with VS Code. This one was really interesting, came out a few months back, became quickly a bit controversial. It's called Devin. And they didn't say AI coding assistance, they said AI software engineer, and people freaked out. I remember when this first came out. And they released a bunch of videos talking about it. I don't know how many of you have seen it, but the videos were pretty interesting. Things like the AI sets up the project, the AI does all, the AI is at the command line, the AI is setting up projects, it's setting up source code, it's doing a lot of work. But since then, people have been kind of calling them out on it. It really isn't available yet. And then there's the large language models, and this is where I started when early last year. There's Claude, which is very good, from Anthropic, and of course there's Google Gemini and OpenAI ChatGPT, which is probably the most famous ones. All 3 of these things, all 3 and all these other tools were kind of in this race. The capabilities for coding in particular, but just the general capabilities of these AIs just keep incrementally getting better and better and better. at substantially rapid rates. It's really interesting to watch and to play with. So I want to show you an example. So I'm in VS Code, and this is something I did a while back, but I'm in the chat on the side here, and I just said using the currently open file as a reference, create a new class named shipping orders view. The class contains two queries, one query that selects by customer ID and another query that selects shopping orders by a from and to range of ordered at. And then both queries do paging. And then the A comes back and says, sure, okay, here's your code. So here's the code that it generated on the left. This is, I go, thank you very much, because it's like, there's some tedious code in here, you know, these annotations, the SQL. Maybe it's not exactly right, but bam, you know, it's like, okay, I got a lot of code. So I don't know how many of you have been using AI coding assistants. Can I see a show of hands? Okay, it looks about 50%. So it's pretty wild. So that's one example. Here's another one though, and hopefully it'll work. I'm in some code, and yeah, it's going to work. So I just, you know, I just hit enter, and you can kind of see this kind of grayed out code they call ghost code, and it said, oh, I think you want to write this. I go, okay, yeah, that's right. And it goes, oh, and I think you need this block of code. All right. So if you haven't used these things before, it's like, holy crap. You know, and then not only is this a block of code, but it's a block of code that's in my style of how I want this code to be written. It's like, you know, when this happens to me, it's like, you're in my head, you're reading my mind type of thing. It doesn't always do this, but it does do it quite often. I'm done, right? This block of code is written. Now, I kind of bootstrapped it because I wrote a few of these, you know, it's kind of a pattern before, but that's just a quick example of how these AI coding assistants work. It's pretty significant. So that was a very quick introduction to AI coding assistants. So let's jump into part two, the micromine services. What do I mean by this? So first, what I want to say is what I don't mean by this, because I use the word mine, but this isn't about ARML. And I want to point out that the type of programming that I do, I'm primarily a back-end developer, but it doesn't matter if you're a front-end developer or back-end developer. The type of programming that we've been traditionally doing and the type of programming that they're doing for the AIs, they're on a completely different, it's a completely different dimension. How that code works, the kind of data that it uses, things like that is utterly different than everything I've been doing for decades as a developer, and I think for most of us. But what I'm going to try and show here is that we can do some things that start to take advantage of what we're learning about how we can build intelligent software. So what this is based on is event-driven, an event-driven type approach. But bear with me, because I'm going to link it up to what's happening in some of the AI stuff, because it's fully event-driven, and I'll show you what that means right here. So this is a design diagram of it's not a pretty picture, this is a design diagram of a real system. So I'm a developer advocate now, so I don't have to write production code anymore, but I wrote tons and tons and tons of production code. So when I write demo code, I like that demo code to be at least somewhat non-trivial, you know, at least interesting. So this is a demo application, but this is real. This is my design. I'm just kind of showing it in this fancy way. The thing I want to show here, though, is that these diagonal boxes represent small focused services, like a small focused microservice. All right. When it lights up, that means it got a request and it performed some kind of an operation. Because it's event driven, that operation emits events. Now those events may be of interest to other components downstream. So you can see the highlighted line here at the top left, where the the highlighted service on the very left, is lit up, has a lit up line that is going to another service. So that triggers that service to react to it. So an event comes out which triggers a command going into another service. That service reacts to it. And another service, and another service, and another service. So there's this cascading sequence of events. And what I'm showing you is the processing flow in this application. I use this as I'm writing the code for this application because it's event driven. And in order to kind of keep everything together, I need some kind of visualization of the flow. But it's a really interesting and very different way of coding. What's even more interesting is that in this particular case, in this diagram, there's only 3 shapes, and they're called components, and there's only 3 types of components. So the first, that diagonal box I said is like a small focus service. It's called an entity, and if entity is kind of a clue, an entity is like a unit of state, right? A shopping cart, an order, an IoT device, a person, whatever, those types of things. But then the other shape on the bottom is that V-shaped thing. That's a view. So in event-driven, you often hear of CQRS, which is Command Query Responsibility Segregation. It's kind of a fancy acronym, but basically what it means is that commands that perform state-changing operations happen in the entities. The queries, the reading, happens in the views, because event data isn't very queryable. So you need to take event data and transform it into queryable data. But they're separated from each other. That's the segregation piece. And then the third component, which is very interesting, it's called, in this particular tool, it's called an action. But the action is, its most common use case is it's subscribing to an event stream in most cases. So as events come in, it will take those events and transform them into commands that it sends downstream. But this whole system was built just using this pattern of these 3 components. Now here's where I kind of push things. As I was getting deeper into this, and I was, like I said, I'm very interested in what's happening with AI, and I'm very interested in neural networks, and I've been very interested in biological neural networks as just as a citizen. I'm not in that space, but there's tons of material out there on it, and I find the neural networks, both artificial and biological, extremely interesting. And it occurred to me, it's like, wait a minute. This coding style here kind of has this feel that these entities are like neurons, and these actions are like synapses. What a synapse is the junction of signals coming out of one neuron going into another neuron. So it has this flavor, or this feel to it that does this. But back to reality a little bit, this system just works on processing cascading sequences of events. And that's what this micromind is. So I want to show you a little movie that I did from real data of this application running I just took log data and I projected it. I never get to watch it on the screen. But so what's happening here is the dots represent units of state. The lines are events coming out that get transformed into commands. And here's what's happening right now is the system is processing around 200 orders. And what the system does is it's not just taking in orders, but it's allocating stock to orders. The behavior of this application is it's doing this stock allocation. And it's not just decrementing counters, it's actually tracking physical units of stock. It's remembering where every single physical shippable unit of stock goes in this system. So on the right is stock, on the left is orders. The red represents orders that are in a backorder state because there's insufficient stock. So another behavior of the system is that when it runs low on stock, it orders more stock, and when the stock comes in, it goes looking for orders that need stock. So there's this really interesting behavior that's happening here. And when everything turns green, all the orders have been processed. But I wanted to visualize it this way, and this is where the whole micromind thing is. You may have seen some videos. There's some really interesting videos of like the neural activity in an insect brain that has 20, 30,000 synapse or neurons in it. And it looks very much like this, but this was generated from real data of that design diagram I showed you, doing real work. And then the code I wrote to do this, by the way, I used ChatGPT to write the code because the the code I use Blender to do this. Blender is an open source tool for 3D videos and visuals and stuff like that. Has a very elaborate API. I'd never used the API before, but I was able to write about 800 lines of Python in a couple days to consume the data from my log file and create this movie. It was a blast. It was a blast. So the concept here of this micromind is I feel like it's got this biologically inspired event-driven processing flow. Biologically meaning, there's this kind of neural processing feel to it. Because with biological and artificial neurons, the way they work is a signal comes in and it may or may not trigger the neuron to send a signal out. What's really crazy here is that this mechanical process of neural networks, it has this elegant simplicity, but this profound cognitive complexity and just these stunningly powerful capabilities. So think about this, is that humans showed up with this massive biological neural network between our ears. We have about 86 billion neurons is the number most people say that we have in a human brain. And there's trillions, hundreds of trillions of connections. Like a neuron typically is connected to 10,000 other neurons through 10,000 other synapses. So there's trillions of synapses. But this neural network, this biological neural network showed up in the planet Earth, and we took over the planet. Now, the same processing model, it's not exactly the same, but it's fundamentally the same. These artificial neural networks are coming along and they're kicking our butts, right? I mean, they're changing the world on us. So the point is that this kind of neural processing pattern is really powerful, and using this relatively non-AI type of programming style, this neural kind of programming style, I've been really shocked by how simple it is to implement it and how powerful it can be. With this just relatively simple flow, commands come in, events come out. Events get transformed into commands going downstream, triggers another event, the event triggers a command, and so on. That's the pattern here. These entities, they're just objects. Like here's a shopping cart. I'm just showing an JSON. It's just an object, right? It's kind of a distributed, durable state object, but nevertheless, it's an object. So how's this all fit into AI? Well, like I said, it's modeled after the power of the processing pattern that we're learning about very rapidly. We're all getting schooled on this very quickly, on the power of neurons, both biological and artificial. But the other thing is that this system and the systems built in this way is composed of relatively simple components, software components that don't get big, don't have hundreds and hundreds of lines of code. They're typically very focused and very small. And AI programming assistants, AI code generation loves this kind of stuff. It's almost a form of prompt programming in a way, because the reason why that quick demo I showed you where it deduced the next method to be written, it was looking at all the code that was there and it was deducing, oh, I think that the next thing that needs to be written is this. So because it was following the patterns of the code. So these AI assistants really, they pick up on patterns and reusable code patterns very quickly, and they can repeat them over and over again. So here's some source code. You can see this is the definition of an API of one of these entities. And you can see it's just, this is like Spring annotations that are here if you're familiar with Springs. But you can see there's 3 APIs defined. This is all basically a recurring pattern. And this patternistic approach for writing the code works well. But here's where we fit in, I think, is that, okay, fine. The AIs can write the code, but the big picture is much harder to do. As an example, we've been trying to get that last 10% of self-driving cars for a long time. We're not quite there yet. The cars can drive pretty good, but that last part of full autonomy for the vehicle is very, very hard. So there's this, I don't know how long this will last. It may last a long time, it may last a short time, but I think where we fit in real well is we can take very ambiguous, this is what we do as developers and architects and designers of software systems, is that we take and start with like very ambiguous requirements, specifications, and we drive down into very specific specifications, ultimately into the code itself. The code is the ultimate specification. But we have the big picture. We can have the big context window. You know, they talk about context windows in AIs and they keep getting bigger, but we have a huge context window in our brains. And so this is where I think we fit in, is the big design, the conceptualization down into those components. Then let the AIs help you write the components. So that's what I'm getting at here, is that the AIs can help you write the components, but the design is something we do, the overall design of the system. Using patterns, though, at this level. So I want to just very quickly go through it. If you heard of the saga pattern, the saga pattern is kind of a step-by-step type of a process with contingency plans for what happens. So there's all kinds of different patterns there. I'm going to just go through it quickly, but you can see that there's 13 of these entities, and most of them are implemented using some form of pattern. This last one, this reduction tree, there's like I said, there's 13. 4 of them use this reduction tree pattern. It is a tree, a data structure of a tree where the leaves have detailed information, and that detailed information gets reduced down to the trunk of the tree. So it has these patterns. So it's kind of wild. Here's another design. I'm just kind of flipping back and forth, completely different application, but the same patterns are used in designing this type of a system. And here's kind of a side-by-side real quick of something that's a little bit more complicated, where this is where stock's getting allocated to orders, or in the other application where deposits are being consumed by withdrawals. But there's a symmetrical side to it where the flow can be reversed, that stock can go looking for orders instead of orders looking for stock, and deposits can go looking for withdrawals instead of withdrawals looking for deposits. So same pattern used in both applications. So it's solid design patterns. It's and it has the characteristics of like do one thing, do it well, loose coupling, asynchronous communication, state isolation. We've been talking about these kind of characteristics for microservices for years, ever since microservices came out. Another one, though, is this is really good for distributed types of systems where these different operations can happen in different space and time. By different space and time, meaning on different machines, something happens here and something else can happen there, and they're not locked together in some kind of a synchronous processing flow. So let me just get into the test-driven prompt programming part 3. So right now, the general view of AI programming assistants is they help us write, we prompt them, and they help us write our source code. And I'm going to just push that. It's like, okay, let's flip it. Imagine that the source code is the prompts. The code that gets generated, we don't care. All right. The analogy is that that first off, many of you might be reacting, oh no, I got to see the source code. But we've been through this before. If you look back in the history of programming, we programmed in binary first, and then we had to introduce assembly language. And the binary programmers go, oh man, no way. I'm not going to this assembly language stuff. You guys are nuts. Then the assembly language took over. So the assembly language settled in. Before we could catch our breath in that one, along comes things like C and Fortran. And the assembly language programmers go, oh man, no way. I need to have the control of the machine. I'm not going to those new languages. So there's always these big changes that occur, and there's always this kind of inclination to resist those changes. So what I want to push you here, say, think about it. Your source code is your prompts. You don't look at the generated code. We don't care. That's our new, the Java or JavaScript or Python or whatever it is. That's the new assembly language. The idea is that what we're building is human and machine readable prompts. We understand them because it's in our language. Machines understand it because they understand our language. But there's a technique to it. And this is just an introduction. This isn't something real. This is just me kind of hallucinating myself. But I think the style is results-oriented, test-oriented. That's why I said test-driven prompt programming. So you're writing the prompts with the results in mind. What do you kind of tell me what this code should produce given a certain different kinds of scenarios. And it's iteratively developed until the prompt is sufficiently unambiguous. But it's not like you're writing one prompt for a complete application. You're writing prompts for parts of the application. Right? So here's an example. This is a prompt. So what I did was, and I've been kind of refining my prompt technique, and I use all the different AIs all the time. I've got subscriptions to them all. And I just keep going back and forth and trying different things. But one thing I do is I call it warming it up. So we get into a conversation. So I had a conversation before this, and I was talking to ChatGPT, and I was explaining this idea of test-driven prompt programming. We went back and forth for a while until I kind of got sufficiently warmed up on the topic. And then I said, all right, please provide an example test-driven prompt, such as the process of a customer adding an item to an order, such as adding an item to a fast food order. And it goes, all right, here you go. And the prompt that came back that it wrote for me based on that very short definition was prompt functionality, add item to order, user story. So it created a user story, input specification, the expected behavior. So it has some expected behavior. Now at the very bottom, you see system recalculates the total price of the order. That one's probably too ambiguous. I probably need to provide more detail, like, okay, exactly how do we calculate the price? How do we do taxes and things like that? But the point is that we aren't writing the prompt ourselves. We're actually using the AI as a partner in writing these prompts that will develop things. So it comes back with constraints, and then finally it came back with the test cases. And it's like, okay, this is pretty cool. It wrote this for me, and now I've got a document. This is my test-driven prompt. I can go back and refine this with the AI. I could tweak it and whatever, and then have it generate code and generate tests, and until the results are what are expected. So if the results aren't what are expected, well, maybe I don't have sufficiently well-defined and unambiguous test specifications or something like that. And so a lot of people ask, well, do you trust the code? And it's like, so my quick response to that is that, say you're a team leader and you're delegating all these, responsibilities for writing code to me and to these guys here and whatever, right? So what's the difference between you delegating responsibility for writing the code and a test to other people and expecting them to come out with the good results versus with an AI? We have processes to make sure that the systems works well, and I don't see that huge of a difference between this. So the idea here is that, back to this design, is that there would be prompts for all these different components. Not a big prompt for the whole system, but each little prompt writes a little bit of code, right? And so my source code is a bunch of prompts that define how to write all these different components and how everything's wired together. Something along those lines. The AI starts to learn these patterns. It can start to maybe, on a single prompt, to generate multiple things working together. It's producing the source code. I don't care. I don't look at it anymore. So the idea is that you have systems if you have systems that are composed of tightly focused, loosely coupled components, they can build systems with surprisingly powerful behaviors. So, is test-driven prompt programming the future? I think some form of this is what's coming. And the main thing I want to leave with you is that just flip this. Stop thinking about, today use AIs to generate our code. Tomorrow, that's probably not going to be the case. That's my main point here. So I covered the three parts. The future is now. The AI coding assistants. The point I want to make here, I know I've talked to a lot of people about this. A lot of companies are the ones that are holding back on adopting this for all kinds of good reasons, but you have to figure this out. if you're in a company or in a place where you haven't started to use this stuff and get a feel for how it fits into your style, your organization's style of developing software, you got to do this. The longer you procrastinate on this, the further behind you're gonna get. This micromind style, this is more concrete. I've been programming this style for a long time, and I love it. It's been a lot of fun. And then this test-driven prompt programming, that I'm just kind of speculating on the future. But the more I've been thinking about it, the more I've been talking about it, the more I think that this is the direction that we're heading. So I want to leave you with this. That I told you about that word vesperance, which is kind of a bit of a downer type of thing. But I tried to come up with a made up word, and I couldn't find one. But I adopted this one word called innovera. And my definition of innovera in this talk is that there's this reaction when an AI does something for you and go, man, that's it. Yeah, thank you very much. A bunch of work. If I had to do this on myself, I would have had to power through it and just kind of tedious work, and boom, it's done. And this happens over and over and over again. And it's like, man, okay, cool. You're reading my mind. Sometimes they say, get out of my head, but just real quick, AIs will not replace you. People using AIs will. This is getting a bit old, but I think it's important. And then this one I think is really important. You have to be able to adopt your learning style. You're going to have to give up things that you've worked very hard to learn and open up your mind to learn new things. So I think this quote from Alvin Toffler was a great futurist is very interesting. So that's the talk. The QR code for the slides is on the top right. The code that I showed you is something that's from my company. It's called Calyx. That's why I'm wearing this Calyx t-shirt. There's a QR code for that down below. Give it a try. You can try it for free, anonymously, all that type of stuff. But everything I showed you code-wise and design-wise is based on this Calyx product. And let me see if we have questions. Room 6. Okay. Can you talk more about warming up the AI? Oh, good question. So by warming up the AI, it's like I think it's called one shot. A lot of people, they go to an AI and they just ask a question. It's just one question and they get the response back. And the idea is that no, get it you and it into the conversation. Like, and another approach is people say, well, you're an expert in blah blah blah, and expecting it to be all right, the all-seeing expert in a particular area. I think it's more than that sometimes. That like if I'm especially like if I'm writing a document or something, or generating an image, I'll write out some description of what I want to do, and the really cool thing is when you say, do you have any questions? And a lot of times the AIs come back and say, oh yeah, this is really fascinating, and I do have some questions. Here they are, and you can answer the questions. So you can get into really complex discussions with the AI and get some really interesting dialogue going with the AI when you have this back and forth kind of conversation. So that's what I mean by warming it up. Talk to it. Ask it questions and ask it to ask you questions. That type of thing. The AI coding support for at the fingertips, isn't that the risk of over engineering higher? If I take it where it's like, well, we're worried about the code that it writes for us, then yeah, it's like, it's not the fully optimized code. But like I said, we went through this before, especially like when we went from assembly language to C and Fortran, those types of things. That was a big resistance because the assembly language programmers felt like they had their fingers on the metal. Right? They knew they were, they were controlling registers, and they could optimize the actual, flow of instructions at the machine level. And then all of a sudden that was gone. But then we don't worry about it. The computers got faster for one, Um, so I think it's the same thing that this will have to mature over time, and we're just have to trust that the code that gets written. But it's like, say you do develop some code, you put it into production, and you end up with the inevitable hotspots, the performance hotspots, the low-hanging fruit. Where is it running slow? Where is it spending a lot of time? Go back to that and fix it. But now the process would be tweak your prompts and go to the AI and say, hey, we have a problem here with the performance. Let's fix it. If you're familiar with recent OpenAI situation, resignations due to security concerns, yeah, that one, we're going to deal with this a lot, I think. So OpenAI is under the spotlight right now because the question is, there was a lot of people that left OpenAI last week, especially the security team, and because there's concern about what's AI going to do? How can AI be used? Yesterday there was a talk on security with AI. So the concern is, okay, now people have, malicious people have these AIs that can do nasty, intelligent things to try and break into a system. But I think we can counter that with, we have AIs that are also fighting back, right? Very smart, very adaptive, those types of things. But this security thing, we're watching it play out real time, and there's a lot of soul searching going on though as well with the companies about this. I think they're acutely aware of it. Would you recommend? I can't read it. Find. Oh, thank you. Find over ChatGPT. Every week it changes. Like for a while I stopped using ChatGPT because Gemini was really picking up the slack. Before that, I really like Claude. But now, as of like last week when GPT 4.0 came out and I play with it again, it's like, wow, okay, this is much better. So this is where it's an advantage to have access to multiple AIs, but they're definitely going to be one-upping each other all the time. So one day one is ahead and the next day they're behind. That's just the way things are happening right now. Let's see. If we stop looking in the code, and as the time goes by, the knowledge of the system also goes away. Who do you think will fix the system? Okay, good question. The knowledge of the system at the level of the code, like Java, JavaScript, or something like that, yeah, you can imagine our skill sets will go away. Same analogy. None of us have any skill set with assembly language programming, right? And we fix it with our higher level of abstraction source code. Think of this prompt as just another level of abstraction. We will adapt to fixing systems that don't behave well at a next level, higher level of abstraction. We keep going up these abstraction levels over and over and over. I mean, think about computer systems. They're just massive layers. Look at a stack trace, this massive layer, abstraction after abstraction after abstraction. So yeah, I think the initial reaction is it's a legitimate reaction. It's like, oh man, I'm going to forget how to write code. It's like, yeah, you are. But your new skill is going to be how to articulate unambiguous prompts that drive the behavior of systems in very precise ways. And there's going to be techniques and styles and expertise at that, and we'll be kind of up another level, and we'll go up another level up beyond that. So I think we have time for one more. How safe is AI add-ons in terms of code leakage? So by code leakage, I guess you mean that it's leaking out to other people. It's like, if you want to look at my code, even though it's proprietary, have a ball. It's my feeling. It's like, you know how hard it is to understand your own code when you go back into it months later, right? So we're expecting people to steal our code. I think it's more involved than that. So the the company knowledge, the company jewels are at a higher level as well. It's the bigger functionality, not the low level functionality, I think. Although that is a legitimate concern. And so one thing that can be done is you can have your own private AIs on premise. Nobody gets to it but people in your company, and nobody can steal your intellectual property. So we're out of time. Thank you very much for attending the talk. I really appreciate it.